Welcome to Powerbench. In this video I'm going to be doing a Big Clive copycat special. He's recently reviewed these Poundland USB light, Christmas light phone charger cable, and they're not very good. They seem to have forgotten the current limiting resistor, which means the LEDs are driven far too hard. And everyone loves a terrible product review, so let's have a quick look. Bit of paper. And the lights. Now the ones that Big Clive had a repeating colour pattern, much as these do. They seem to be pretty horrible looking. Micro USB. Bit of strain relief, regular USB, bit of strain relief, not a lot though. So normally with LEDs you want to draw a relatively small amount of current, somewhere in the region of maybe 10 milliamps to achieve a reasonable brightness level. So just to demonstrate that, I'm going to hook these up to the bench power supply, and I've limited the current to 10 milliamps at 5 volts. And we'll dial that up slightly. So you can see here, they lit up and they look reasonably. Let me turn the lights down. There we go. And they lit up, they look reasonably decorative. So if we crank up the power, so that's at 30 milliamps. So now drawing 50 milliamps, and they're looking pretty bright. I mean, these would be bright enough for a brightly lit office at this point. Now that's, across all the LEDs, that's okay. Nothing too bad about that. Let's go higher, 100 milliamps, 200 milliamps. Yeah, they're definitely drawing more than they should. So standard USB is up to 500 milliamps. And they're still drawing more than that. And they are very bright now, almost too bright. So these are in the process of running themselves way too hard. They're going to stop working. So they're currently drawing a full amp. Not ideal. Oh, there we go. So the first one's gone pop. Got suspiciously dim. So, not very good. Let's just run them off a power bank for comparison purposes. And they look now very much. Plug them into a meter. So they're currently drawing. Now they're slightly broken. But they're still drawing 400 milliamps. So, yep, mine are as broken as Big Clive's are. That's far too much power for LEDs to draw. Well, yeah, and one's now gone out completely. The rest I suspect will fail fairly soon. But that's what we expected to happen. And what I actually want to do is the standard test. So we'll dial this up to the standard level, 5 volts, normally 5.14, plug in a little meter, turn the output on, 2.1 amps, give it a second to settle. So I just want to know how terribly cable these are, because that's what we do. There we go, close enough. So What I'll do is plug these into the meter first. The load, sorry. I'm not expecting great things because they are powering some terrible lights. So the voltage drop, 4.27 volts. So we're losing 3/4 of a volt across the cable. Some of that is likely, well, maybe not actually. So the where are we? 2.34. So these are currently drawing the LEDs are currently drawing about 200 milliamps, and we're losing 0.7 of a volt across the length. So these will stop working eventually, and then I suspect they'll get a little bit more efficient, but predictably these are not very good. They don't work properly, and you're wasting quite a lot of power in this cable. So if you're running it off a power supply and you don't care, that would be alright if they worked, but they don't. So I can only recommend what Big Clive said: do not buy. These are terrible. Thank you for watching Powerbench. See you soon. Just for the sake of completeness, the lights are on. 0.7 volts drop. Let's find out how terrible the cable is without the lights part of the circuit. Even worse. So without the extra current carrying capacity of the lights cables, it's now losing 0.8 of a volt. So, just for the sake of science, 0.8 divided by 5 times 100, 16% loss. So it's not even a good cable. Rubbish, don't buy.